So there are two ways you can do this. One, the simplest way, is to use the special formula for the sum of solutions or factors. Well, if you have a quadratic equation, ax squared plus bx plus c equals 0, then the sum of the solutions or factors is just negative b over a. So in this case, that would be negative 5 over 1, and that's negative 5. The second way you can do this is to factor everything out, and when you do that, you'll get x squared plus x3, x plus 3, x plus 2 plus x plus 3 is equal to 0. So that means x is equal to negative 2 and negative 3. And this adds up to negative 5 as well. Okay, 21. What is the quotient? So first, let's just put this in a fraction. And then we're gonna write out the prime factorization of 1000. And that is 2 cubed times 5 cubed over 2 cubed times 5 squared. And now you can do some simplifying. You can get rid of the 2's, and you can get rid of the 5 squared. And then you'll just be left with 5. And that is your answer. Twenty-three. So you have 96 girls, 54 boys, 68 7th graders, and 82 8th graders. And you know that 40 of the girls are 7th graders. So if 40 of the girls are 7th graders, then that means there are 68 minus 40, or 28 7th grade boys. And if there are 28 7th grade boys, then that means there are 54 minus 28, or 26 8th grade boys. And that is your answer. Uh, 24. What is the largest sum? Yeah. So your first digit will be 7 and 6. And then the problem says that 0, 1, and 2 cannot occupy the same position in both numbers. So let's just say that we're gonna have 2 be here, 1 here, and 0 here. The next biggest number after 2 is 1, 2, and 0. So that's a possibility. And if you add this up, you get 13, 3, 3. Oh, I did something wrong. Oops. Just kidding. Yeah, let's just put 0 here and 2 here and see what happens. You get 13, 3, 2, 1. No, just kidding. You get 1, 2. And you can actually make this bigger if you do this. If you do this. There. Now you have 13, 3, 21. And that's the biggest you can get. So that's your answer. 25, how many pairs of positive integers x and y are solutions? So for this problem, we're gonna turn everything into one fraction. So our common denominator is 36, and our numerator is 3x plus y. This is equal to 1. Now if you cross multiply, you get 3x plus y is equal to 36. And to find how many pairs of positive integers there are, we just have to find how many integers work for x. And to do that, we have to find how many multiples of 3 there are that are less than 36. Yeah. So you can solve all this inequality, divide both sides by 3, and you get x is less than 12. And since x has to be positive, you can put that here. And now you can see that there are only 11 possible values for x. And whatever value x is, then y has to be an integer as well. So that works out. So yeah, you have 11 pairs. Ooh, 26. Yeah, this problem requires a bit of thinking. Yeah. So here, we're going to do it this way. This thing can turn into 57 minus 2 times 57 plus 2. Since 57 minus 2 is 55, and 57 plus 2 is 59. Yeah. And then, this thing can turn into 55 minus 2 times 55 plus 2. And this is equal to x squared minus 1. Now you can simplify this a bit. You can simplify it a bit since this thing is just equal to 57 squared minus 2 squared. As you recall, we're going to be using this little formula to help. And this thing turns into 55 squared plus 2 squared, since there's a double negative there. Oops, I got it. Yep. Now, since you have a negative 2 squared and a positive 2 squared, then you can get rid of those. They cancel each other out. And you're left with 57 squared minus 55 squared. And you don't have to calculate the squares. You can actually just expand this to 57 plus 55 times 57 minus 55. This is just easier to calculate since it's just 112 times 2, which is 224. And if you remember all of your squares, then you know that 15 squared is equal to 225. So 15 squared minus 1 will be equal to 224. So that means 15 is your x. 27. Okay. Yeah, this problem also requires some thinking. A lot of thinking, kind of. And you just have to find a pattern or a relationship between these two equations, or these two theorems, patterns. Yeah. You have to find a relationship between these two. And once you find that relationship, it gets pretty easy. So the relationship is just like 1 cubed plus 2 cubed plus whatever, all the way up to n cubed is equal to, okay, this first part comes from Nico, Matt, whatever his name is. And this is equal to 1 plus 2 plus 3, okay, all that, dot, 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 all the way up to n squared. And this is equal to s squared in our case. And yeah. So basically, we can solve for s. S is just equal to the square root of all this, or just, we can just square root this equation to get 1 plus 2 plus dot, 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 all the way to n. And in our case, our biggest number, our n, is 8. So you can solve for s here using the special formula thingy. If you have n terms, n plus 1 divided by 2, that's the formula. This is the formula to solve something like this. If you have like a continuous sequence kind of thing. And yeah, so that is 9 times 8 divided by 2, which is 36. And that is our answer. What's the area of triangle ABC? Okay. So first we want to find what the radius of the circle is. And we know that pi r squared is equal to 4 pi. So that means r is equal to 2. So our radius is 2. Okay. Oh, oops. Let me just draw this real quick. I'm going to connect the center to all the tangent points on the triangle. We're going to call this point x, y, and z. And all of these tangents form right angles. Okay, so our radius is 2. Oh my goodness. Okay, our radius is 2, and now we want to find the side lengths of this triangle. So we know that AX is equal to AY because of this tangent thingy. And we also know that YC is equal to ZC. And AX and AY is equal to 6 minus 2, since we're given that AB is equal to 6. Oh, that's ugly. That's a 6. So that is 4. 4 and 4. Now we just need to know what YC and ZC are equal to. And for now, we're going to call that D. And we're going to solve for D by using the Pythagorean theorem. So 6 squared plus BC, which is just 2 plus D squared, is equal to AC, 4 plus D squared. And now we can expand this to get 36 plus 4 plus 4D plus D squared is equal to 16 plus 8D plus D squared. And now we can simplify this. We can get rid of the D squared and we can move the D's to one side and we'll get 4D is equal to 24. So that means that D is equal to 6. Yeah. So now that we know that, we can find that BC is equal to 2 plus D, or 2 plus 6, which is 8. And we can solve for the area. Half times 6 times 8 is equal to 24. That's your answer. Oh, 29. So U has a bunch of coins. Oh, and he tosses them all up in the air and he wants to find what the probability that the total value that land heads up is 30. Yeah, this is a bunch of casework. So one case is that you get 3 dimes to land heads. 3 heads. 3 dimes that are heads. And that means that the rest are all tails. So there's only one way of doing this. Yeah. So the next case is you land all heads for 2 dimes and heads for 2 nickels. Now here you have to choose which 2 dimes land heads. So you do combinations 3, choose 2, and then you multiply it by how many possibilities you can get to flip heads for 2 dimes. So that is combinations 4, choose 2. Then you multiply this out. That is 6 times 3, which is 18. Next case, you can get 2 dimes that are heads, 1 nickel that's a head, and 5 pennies that are heads. So in this case, you do 3, choose 2 again to choose which 2 dimes are heads, and you do 4, choose 1 to choose which nickel gets heads. And then for the pennies, you don't really have to do anything since all 5 pennies are heads, so there's only one way of doing that. And you can multiply this all out to get 3 times 4, or 12. Okay, next case, 1 dime is a head and 4 nickels are heads. And in this case, you only have to choose which dime is the head. So 3, choose 1. And there are only 4 total nickels, so yeah. And this is equal to 3. And for our last and final case, 1 dime is a head, 3 nickels are heads, and 5 pennies are heads. So once again, you choose which dime is a head, multiply it by which 3 nickels are heads, and then there are only 5 total pennies, so that's just 1. And this is equal to 3 times 4, or 12. Now you just have to add all this up. So 1 plus 18 plus 12 plus 3 plus 12 is equal to 46. And since it's asking for a probability, we put 46 over the total number of possibilities, which is just 2 to the power of 12, since there are 12 coins, and for each coin you only have 2 options, heads or tails. And yeah, now you just have to simplify this. And 46 divided by 2 is 23, which is an odd number, so you can't simplify this anymore. So now you just have 23 over 2048, and that's your answer. Okay. 30. 30 is just such a long problem. There's too many. Well, it's not even too many steps. It's just a lot of work. A lot of casework. So yeah. Okay, we're gonna need a lot more room for 30. Okay, we're gonna start with our first case, case 1. And for this case, basically you have 2 terms, A, B, C, D, or E. 2 of these terms equal to 1, and the rest are 0. Yeah. So for this case, you can split it up into more subcases. And for your first subcase, you want A, C, or E. From A, C, or E, you want to choose which 2 are equal to 1. So how should I write this? So okay. Oops. Choose 2 from A, C, or E that to be equal to 1. So to do this, you basically just have to choose which one is actually equal to 0. So you just do 3 times. 3, choose 1. And that's equal to 3. For your second subcase, you want one of A, C, or E to be equal to 1, and you want one of B or D to be equal to either 1 or -1, since it doesn't really matter, since they have even exponents. Okay, so for this, you only have 3 choose 1 cases, and you're going to multiply it by 2 choose 1. or just 2. And then you have to multiply this by 2. Okay, this is from here. So for this second thingy, where you want to choose either B or D to be equal to either 1 or -1, first you have to choose whether B or D is equal to these two, and then you have to choose if it's equal to 1 or -1. So it's just 2 times 2. Oh no, okay. And this is equal to 3 times 4 or 12. Okay, sub case 3. Basically, B and D are equal to either positive, -1. They can be equal to either -1 or +1. And there are 2 ways of doing this. 2 times 2 ways of doing this, because B can be either -1 or 2, -1 or 1, so that's 2 possibilities, and D can also be either 1 or -1. So this is all for case 1. Now we just add up all of these. So 3 plus 12 plus 4 is 19. Now we can do case 2. This is so much work. Okay, case 2, we want 3 terms to be equal to 1 or -1. Okay. And then we want 1 term to be equal to -1. Yeah. Oh, we want 3 terms to be equal to 1. We want 1 term to be equal to -1. And then the rest are 0. So you have one subcase. So subcase number 1, both B and D are equal to 1 or -1. And we already calculated that here. So there are just 4 cases. But we have more. We also want one of A, C, or E to be equal to 1, -1, or 0. It doesn't really matter. And to choose which letter is equal to either one of these, you do 3, choose 1. And then there are, hold on. Okay, let me restate that. That was confusing. This entire problem is confusing. Okay, so basically you want A, C, or E to be equal to B, 1, -1, or 0. So one of these values correspond with the letter. So each letter gets a value, and they have to be either one of these. And they have to be different. So to do that, well, first we can look at A. There are 3 possible values for A. Then we can look at C. There are only 2 possible values for C, since the other one was taken by A. And that leaves E with only 1 possibility. So that gives us 6. And then for this subcase, we have to multiply these together to get 24. Okay, subcase 2. This is the last one. So one of either B or D is equal to either positive or -1. So that means that the other one is equal to 0. And to do this, you have to choose B or D, so 2 possibilities, and then you have to choose whether it's 1 or -1. So that's also 2 possibilities. Multiply those together to get 4. Okay. We have more actually. 2, and then you have to choose 2 from ACE. Choose any 2 of these letters, and then they have to be equal to 1. Both of them equal to 1. That means that the other, the one not chosen, is equal to -1. And to do this, you just have to choose which one is equal to -1. So that is just 3. Choose 1, which is 3. Now you multiply these together. 4 times 3 is equal to 12. And then you can add 12 plus 24 is equal to 36. So you have 36 possibilities for case 2. And now you have to add case 1 and case 2 together. So that's just 19 plus 36. And that is equal to 55. That's your answer. Oh, that was a lot of work.